Hello everyone, I am Sergii Skurativskyi and would like to present the talk Improvement in the Evaluation of Gamma Radiation from Cylindrical Bodies with Spatially Inhomogeneous Source Activity Distribution prepared with my colleagues at the Center for Information Analytical and Technical Support of Nuclear Power Facilities Monitoring of the NAS of Ukraine. This research concerns the issues of gamma spectrometry. Gamma spectrometry is used to detect highly radioactive sources or to perform general imaging of the radioactive field. As well as the method of gamma spectrometry help to solve the problems in the field of mineral exploration, medicine, environmental monitoring, agriculture, anti-terrorist protection, assessment of the consequences of radioactive pollution, etc. Thus, we should study the radioactive materials, organize their effective control, and provide radiation safety. One of the components of a solution to this problem incorporates the assessment of intensity of the gamma field of radioactive bodies. To do this, the achievements of mathematical modeling are used. In particular, we developed the procedure to describe theoretically the gamma radiation field produced by a cylindrical body containing the source of radioactivity distributed heterogeneously. The research aim and objectives are as follows. The studies concern the analytical description of gamma ray fields produced by radioactive cylindrical bodies, namely disks, when the disk source activity function depends on the spatial coordinate. Next, we develop the semi-analytical procedure, which is based on the representation of the source activity function via the linear combination of step function. The results of utilizing this procedure are compared with the exactly solvable classical case. Moreover, it is considered the non-monotonic source activity function when the application of the procedure can be complicated. To begin with, let us briefly recall classical results. The intensity I of the monoenergetic gamma flux emitted from a point source obeys the relation 1, where Q is the source activity, R is the distance between observation points and the source, mu is the attenuation coefficient. By integrating 1, the intensity I for a thin radioactive disk of a certain radius r satisfy the relation 2. In this case, the source activity Q is assumed to be constant. Now we are interested in the gamma flux of radioactive thick disk of fixed radius and thickness as shown in figure 1. The problem is to evaluate gamma intensity at the point C. By integrating relation for thin disks over the vertical coordinate z, we can evaluate intensity at a distance h from the top of the disk on its vertical symmetry axis and obtain relation 3. Note that when the source activity function is exponential or constant 1, relation 3 admits phasor derivation. Namely, for constant q from 3, it follows the relation 4. When function q is a function of z, in the vast majority of cases, alternative methods should be applied. That is the objective of this research. Specifically, we developed the semi-analytical approach for calculating the integral 3 when q is a smooth function of z. This approach is based on the representation of the function q in the form of the linear combination of step function. To do this, we use the procedure outlined in Vakhnenko's works 1 and 2. Assume that the function q is defined over the range 0d and there exists a number gamma nth, finite numbers. Next, let di be a partition of the domain 0D, suppose that it is valid the following representation 5 in the form of linear combination of Heaviside function theta. Performing simple but tedious manipulation, the nonlinear algebraic equation 6 can be derived for the quantities phi and d. Note dn is fixed, is equal to d. The solution of this system provides us the partition of interval 0d and the weighting factors phi for the step functions. To show the procedure work, we fix the following parameter as shown in the slide, while the distance to the disk h is variable. And consider two cases of Q: monotonic, represented by exponential function, and not monotonic, presented by this relation. The graphs of this function are depicted in the figure 2 in the left and the right panel by solid blue curves. In the figure, it is shown also the stepwise approximation functions when the number of partition points is chosen from 1 to 5. As soon as the source activity function is approximated by its stepwise counterpart, the integral 3 is evaluated analytically using relation 4, and we finally get the relation 7. Figure 3 shows the comparison of numerically evaluated integral 3 and via the formula 7 when the function q is monotonic for panel A and non-monotonic for panel B. Note also that for the monotonic function q chosen in the form of exponential relation, the exact value of integral 3 can be obtained directly. This allows one to compare the results of integral evaluation in different ways. Thus, from the figures it follows that the second or third approximation of function q by step functions can show good agreement with the exact integral value. Let us note as well that the procedure is applicable to the weakly non-monotonic function q, as shown in panel B. Some details of comparison and accuracy of approximations are presented in the perpe. So let us summarize the presentation in the following way. The semi-analytical procedure for evaluating the intensity of gamma flux emitted by a cylindrical body with inhomogeneous source activity is developed. This allows one to get an analytical representation for complicated integrals. Next, we applied the procedure to monotonic and non-monotonic source activity function. When function q is proportional to exponent, the comparison of exact value of the integral and the result of asymptotic evaluation via the procedure was carried out. Even for a small number of step functions in the representations, the results of calculation are excellent. When the function q is essentially non-monotonic, the function profile should be broken down into the monotonic intervals where the procedure works properly. Description of source activity function with the help of step functions relates to the approximation of disk by the layered medium. The studies presented above can be interesting for experts in the area of mathematical modeling of gamma field, as well as for specialists in the organization on environmental monitoring, safety measures, and development of test and calibration installation. That's all. Thanks for attention.